This is the rules management system. Drools is the name of the community project. So what exactly is the rule engine? So rule engine concept comes from artificial intelligence. So that's an artificial intelligence concept. Basically, we are talking about machine thinking and machine learning. We define a set of rules. We define the data model that the rules should use to identify the data that comes into the system. And it should fire the rules based upon the data that comes in. So we make the machine take most of the actions according to the rules that we have configured. So it has got a very complex algorithm running behind it, RETE, RETEOO, that is spelled as RETE, RETEOO. It's a complex algorithm. Most of them don't understand the algorithm because that's a back-end part of it. We don't even have to understand it. If we are able to code the rules and understand how it works, then it's fine. But it's an artificial intelligence because when we say that rule engine is a computer program that delivers KRR functionality to the developer, KRR is nothing but knowledge representation and reasoning. So we represent the knowledge by creating the rule files and providing it to the engine, and the engine reasons out using the knowledge that it has derived from the rules and the data model that we have given it. So that's pretty much it. Basically, it fires all the rules for us on the data that it gets. What exactly a rule is? A rule's structure looks like this. Rule name, it's the name of the rule, and we have when is a keyword. This is the left hand side condition where we have this is the condition that the rule should satisfy for the then part to execute. So this is like when this condition satisfies, then this part of the code gets executed. That's the action part of it. So left hand side is going to be the condition, right hand side is going to be the action or outcome, whatever should be taken when the rule on the left hand side is satisfied. When is a keyword, then is a keyword, and it's the end way should put. So this is the simple rule structure, and basically when all the conditions are met, the rule will fire or some actions will be executed. And below I have given a sample rule. This is a very simple rule. So here what happens is when there is this user is a data model, and whenever a user comes in and if his name is Fedra, then we are printing hello Fedra. That's all. There should be a user object with a name Fedra, and then the condition gets satisfied, and then we print the rule. So there are two constraints here. One, the data that comes in should be of the type user. This is a Java data, Java type, Java class, okay, user. So when the data that comes in, the first check is to check whether the data is of type, whether the object is of type user. If it is user, then the object's name property is evaluated and checked whether it is equal to Fedra. If it is equal, then we are going and executing this line of statement. So this is a very simple example to say what happens, what is there in the when condition, what is there in the then condition. So we'll see the rules engine, how it works. What are the different components in the rule engine? So let's start with the bottom of the diagram. So this is the POJO or the actual data type of the data that is going to flow into the rules engine for these rules that we have configured. So basically we need the data model where in the runtime it will be instances of data model, the actual objects that come into the engine. So when objects come into the engine, the rules engine needs to understand what sort of data is coming. So it will map to the POJOs that it has and find out, okay, this is the object that is coming in. So for that we need to define the POJOs and then we need to already provide it to the rule engine. So how do we provide it? In the initial screen we saw that, right? We saw the knowledge repository. So the POJOs will be developed and the artifact will be deployed in the knowledge repository. And we need the knowledge jars as well, this part, the knowledge jars. This is the actual rules that we write and keep it. So these are the rule files, the .drl files, or the decision tables, the Excel sheets which contains the rules, or those are the rule part of it. So those are also embedded as knowledge artifacts and already deployed to the rule engine before it starts executing. So these are the two stuff that we need to provide to rule engine as input before even it goes live. And when it is live, when it is executing, facts are nothing but the data that comes into the system, and this is the data that is going to be manipulated based upon the rules that we have configured and kept. All these rules are going to be applied on the facts, that is the data that comes in, and that's going to be processed. So these rules are going to be applied on the facts. And whatever the rules, after applying all the rules on this spec, whatever is the outcome, that's your actions or outcomes. So the diagram says the fact model tells the rules engine how to interpret the facts. So when a fact comes in, it need to understand this fact is of what type. That is basically the usage of POJO. Okay, and the rules tell the engines what actions to take when certain conditions are met. So we got the data, we have some certain rules configured. So these are the ones which say when these conditions match in the fact that comes in, these are the actions that we should take. So facts are the data that is going to be processed, manipulated, the rules are going to be applied on this particular data, and the rule engine is the one that does all this task. And actions or outcomes are the actions that rule engine takes after applying the rules on the facts. I think you got this. This diagram is very neat and clear. It's very easy to understand as well. And now we will, before we go any further, I need to clarify a few things for you guys, that what is community project and what is enterprise project. Community project is nothing but the open source projects that they develop. These are the base projects from which enterprise projects that are created or done. So when I say enterprise, the difference between this community and enterprise are enterprise projects are the branded versions of the community projects, and they are provided with support guarantee, 24/7 support guarantee to the mission critical applications or some organizations whichever needs this BPM. Community project is basically used for development purposes, like evaluation purposes, or wherever the developers are using it to just check it out, how the application works and all that. So when an enterprise implements the solution, they go for a supported version of that product. But the thing is, both of them are open source. Still we get the source code in both the stuff, and they're pretty much the same. So the differences are, community projects are updated very frequently. Very rapid development goes on there. They do a lot of research there, and the support, when we use this community project, the support that we are able to get is from the community forums that they have set up. So in this case, it's a JBoss product. So there are JBoss forums available where we can go and ask for help if we run into some issues with this JBPM or Drools. And the other thing is, since it's all developed in a very rapid pace, there is not much testing done. It's not a certified product. There will be bugs into it. That's why open source, these sort of projects cannot be used in the enterprise directly. So for that only we are using this enterprise version of the same projects. What it does is, the difference here is, it's very rigorously tested, and there is a certificate available that this project is devoid of bugs and errors there. And they provide a lot of documentation to us, training. Basically we get supports for it. Whenever there is a hot fix available, we get it immediately. So this is basically suitable for any enterprise-wide project where it is deployed in a mission critical or financial system, whichever enterprise, whatever sort of enterprise that it is supporting. So there are basically 4 important projects that we need to know. Drools Workbench. Drools Workbench is the one which provides all the tooling to us. So that's the project which is reused by both JBPM and the Drools. Both of them use the same workbench to provide the tooling features for both these engines, rule engine and the process engine. Drools Expert, that's the actual rules engine. In enterprise terms, it is Business Rules Management System. Drools Fusion, it's complex event processing feature. So Drools Expert and Drools Fusion combinedly are called as Business Rules Management System. JBPM is the actual BPM which makes this process and workflow possible. This is the Eclipse editor integration that I have shown here. The editor that is displayed there is JBoss Developer Studio that's developed on Eclipse base only. There are JBoss plugins available, and on top of it we get the JBPM plugins. So you see here the UI. This is the process that is created and viewed in the UI in the Eclipse using a process modeler. So this particular thing comes from an Eclipse plugin, which has already implemented the BPMN 2.0, the whole BPMN 2.0 stuff. So we will see what are the features that this Eclipse provides us. It provides us wizards for creating JBPM and Drools project. We will be able to see some, there are perspectives are also available, like the Java perspective, Java EE perspective. We also have Drools perspective. See here, it's a Drools perspective. Also we have JBPM perspective, and we would be able to create a sample JBPM project and a Drools project, just like we can create a Maven project or a normal web application, dynamic web project, such kind of projects. We also have options to create a JBPM or a Drools project. We can say right click new project and then select JBPM and then create a JBPM project. Same way we will be able to create Drools as well. So those sort of wizards comes as part of the plugins that we will be installing in the Eclipse. Basically, I would recommend you guys to use JBoss Developer Studio while we work with these tools. It has got lots of features, and it's very stable as well. It is providing a graphical editor for BPM and 2 processes. This is the graphical editor that it is providing. We would be able to drag and drop items onto the screen and then connect it and draw a process diagram. And there is a properties tab to set the properties for different elements in the process diagram. So this is the properties tab. So for each element that is defined in the process, we would be able to set the properties for it. So we have the description, process, interfaces, definitions, data items. So lots of properties are available that we need to set for each particular element that is drawn in the diagram. So all that we'll be able to do it through this particular piece of editor. This is about Eclipse editor integration. I just want to give you a feel of what are the features that are available while we develop this business process. We saw the Eclipse. Now we will see the out-of-the-box application that we will be interacting with to create business process, to build and deploy it, to monitor it, to work with the workflows and all that. So there is tooling provided for data modeling, process modeling. Various kinds of tools are available within this particular application. So this is the home screen that we are displaying here. This is a sample process designer where I have shown. So there are some menus available here from which we will be able to drag and drop the items. And this one, whichever is displayed here, this is the properties window. So for each element, we will be able to set the properties. And this one here, this is a form modeler. We would be able to create UI forms to get input from the user for a process, or to make user take some action on the data that we have, if in the case of workflows. So that is, those forms can be designed here. So there is a template engine available, and this makes it possible. We can create HTML-like forms here, and automatically they will be integrated into the process, and the data flow will also be managed internally. And even this form creation can be done automatically based upon the data that we are setting on the process. And this screen here, that it shows some process definitions. This is a list of process definitions that we have, and here in this end we have some buttons to start the process, abort the process, and all that. So these are some of the screens that I have provided. There are various screens that we need to see, and we will see in the course of this when we complete this whole JBPM sessions, we would have seen all the screens that are available. So the descriptions are written here. The workbench or JBPM is a web-based application. Yeah, this application is a web application, a Java web application, and it runs on Java's application server. This comes out of the box when we install the JBPM. We get this application as well installed, and this can be run using a browser in URL. So we have this is SOA product. So JBPM is all services. So it has got a repository service to store the business processes and artifacts using a Git repository. So we saw the knowledge repository there. So that holds all the artifacts, but those artifacts should be checked into a particular repository. Those artifacts are available at runtime from the knowledge repository. That's fine, but those repositories, whatever knowledge repository we saw, that was after deployment where those artifacts are available for the process at runtime. Okay, but all these artifacts should actually be checked into some code repository. That's the Git repository we have, like CVS, like SPM, all those repositories. Here in JBPM, they are using the Git repository to store all the artifacts. So don't confuse between the knowledge repository and the Git repository. Knowledge repository is all about during execution time after deployment. Git repository is all about compilation time, the check-in process. So that's the Git repository. And this tool provides a repository service to check in your content into the Git repository already implemented. And then there is a user interface to manage your business processes, like these are the ones, like to model the business process, to create the forms. This is the form modeler, and we have the data modeler as well. I'll be showing you in data classes all that screens that are available, and we would also be able to build and deploy a process from the same UI. And then we have this so this whole workbench completes the whole life cycle of the project, that life cycle of the BPM project, right from authoring stage, that is the modeling stage, to the execution and monitoring stage. We will see the JBPM components in depth. Even this is not having all the components, I just want to keep it high level again, but I have provided you a view of more components than what we saw in the first diagram. So the whole thing is a BPM suite, and we have the knowledge repository at the top that remains the same. Those are the artifacts, the knowledge artifacts that we create, the business processes, the rules, and the Java model. So those are all the knowledge artifacts that is needed by the process engine and the rules engine at the runtime for executing the processes and rules. So that we understand and we keep it aside. Now we come to this whole runtime engine. So this is the runtime of in the JVM. This is what will be, these are the components that will be running as part of JBPM. So what are the components that we have? We have the core engine. This is the heart of the JBPM. So this is the one which makes everything possible. All the implementations are within this core engine. So we have two components to it. One is the process engine and the rules engine. Whatever we saw there, the two main engines, process engine and rules engine, both are integrated within the same core engine. That's why I was saying, when we have business rules as part of a process, the execution becomes seamless because both of them are inside the same core part. It's like they are not even separate. They are all the same if you look at it. And they work on the same knowledge repository and they have the same storage. So since it uses the same knowledge repository, same data, and it is residing in the same engine, the integration becomes very, very easy. Meaning you don't have to, if it is a different rule engine, if it's outside this core engine, then what we need to do, we need to establish a connection to the rules engine. We need to pass the data, we need to serialize the data, then pass it to the rule engine. Again, from the rule engine, serialize it back and then receive the data. So all this kind of stuff is avoided because both of them are residing inside the same engine. That's one main important advantage that we have, and that is the one thing that you need to understand as well. And we have and for the human workflow, whenever a human interaction is required as part of a process, then we need this is the component that takes care of all the workflow logic, the human task service. It's a service, everything is services based, and this is also a services based component. It exposes services to manage the whole life cycle of the whole workflow life cycle of within a process. Okay, and we have this user group component. So what this does is, so when a workflow needs to be executed by certain users, it needs to be authenticated and authorized, meaning the workflow should be assigned to correct person, and we also need to make sure when the person accesses a particular activity and is going to interact with the process, we also need to make sure that he is well authenticated and he is authorized to do that activity. So that is done by the user group. And where does it get its input? It gets its input from the organization's central repository, where they have their security information stored. In each organization it might differ. Here basically it might be an active directory. Through LDAP protocol it should be able to access the data, the enterprise-wide data, and it should be able to allow that particular user to act on the human task via the human task service. And then the other pieces are persistence and audit or history log. So these are the other two services that are used by the process engine. So the process engine interacts with all the main components that we have: the human task service, the persistence, the audit or history log. Persistence is basically used for it's basically used for whenever a process fails in between, then we need to kickstart the process in a different JBPM instance, or maybe we need to kickstart that process in a different server itself. So at that time, we need to know the point from which it needs to be started, like when did it fail, and right from the next point we should be able to start the process activity. So in that case, this persistent service will act as a checkpoint for the process engine to understand from where to start the service. That's where this persistence comes into picture. Audit or history log, this is nothing but like whatever has happened in the process engine, we have the audit history. We would be able to derive metrics around it. We would be able to draw some charts around it. So that's human readable data that we have in the database. That's basically to say what all processes have executed, like how much time each task and an activity has taken, the whole process has took how much time, what are the users, who are the users who have interacted and provided input to the processes, what was the data that has flown through the process. All sorts of information and metrics would be captured in the audit or history log, and that will be used for the business activity monitoring as well. So that's those are the components at an high level that the JBPM uses. So as we saw, the core engine is the JBPM's heart of JBPM. It's a pure Java component. That's very important. The whole thing is Java. It is a module that executes the business processes and rules. Yes. It interacts with other modules such as human task service, audit or history log service. Yeah, this is the interaction that happens. And yeah, so again I've explained all the JBPM components. We have the knowledge repository. Knowledge repository contains the process definitions, business rules, domain models, and all of the knowledge artifacts. So this is the knowledge repository. This contains the business process definition, the actual business process diagrams, the business rules, the .drl files and decision tables, all that, and then the Java model. So all these three are the knowledge artifacts. And the main thing to notice in JBPM 6, they have done a slight change from JBPM 6. The knowledge repository that is going to be used is Maven repository. So this is the difference here. So this is the knowledge repository is a Maven repository, meaning when we have developed the knowledge artifacts, we would be deploying all those artifacts as part of a Java project as a jar file into the Maven repository for other applications and other services to use them. You got it? We draw these diagrams, we draw this, we write these DRL files. At last what happens, we make these files part of a Java project, a simple Maven Java project. We build it and then deploy it into a Maven repository. Once deployed into a Maven repository, it's available for the process engine to use that project and execute the knowledge artifacts that we have deployed at runtime. So that's a very, very key differentiator. And now I think you would have understood the difference between the knowledge repository and the Git repository. Knowledge repository is nothing but a Maven repository where only after deployment, where only after build and deployment it can reside in that repository. Otherwise, all the components that we are developing, all the files that we are developing is going to be checked into the Git repository. So again, I'll repeat: the files, the process definitions, the business rules, the domain models, and any other knowledge artifact that we create, like decision tables, anything, everything goes as part of Java project in the resources directory. We compile them as a jar file. Here they call it as kjar for knowledge jar, and then deployed into the knowledge repository. And doing runtime, the API is able to access it, or any application that implements JBPM service layer, it will be able to access the Maven repository and access all the knowledge that we have created to apply them on the data that flows through the business process. So that's about it. And then we have the process definition itself. What is a process definition? It's nothing but a diagram, just a diagram. It's just a static representation. It does not. It's a static representation of the business process. Plus, additionally, we would have given it some property configurations which will be used at runtime during its execution stages. So that's what process definition has. It just has a representation of the business process, a diagram of the business process, plus execution details configured in the properties of the elements that we draw, and during execution time, those properties will be used for those execution purpose. And these definitions are created using the XML standard BPMN2. That's a business process modeling notation version 2. And we have the business rules. These are the .drl files or the decision tables that we create. Again, these will go as part of the knowledge repository as a jar file inside the Maven repository. And these artifacts will be used by the Drools rule engine during execution. And then we have the domain model. Domain model or the actual data types. This is the data model. Basically, these are the type of data that is going to flow through the application. So we have created a business process application. So the data that comes into this is going to be of this particular domain model. So that is what we already define and keep it. So how do we define the data model? It's all POJOs again. It's all Java. So in Java, the domain model is POJOs. So we create the POJOs, and even that becomes part of the Maven repository. Okay, and the domain model can also be declaratively created using domain modeler. So there is this UI tooling also being provided, wherein you can go and just type the variable class name and say create, click create button, it will create a Java class for you, and then create the properties names and then data types from the drop down and all. You'll be able to visually create the Java object instead of going and typing the code into an editor. So that feature, that tooling feature is also provided. The other component that we saw, the human task component, basically it's used for allowing humans to interact with the business process. It's also called as task service, and the process engine always delegates the work to the user task whenever a human interaction has to happen. Process engine doesn't do it. The specific human task component that implements the whole managing of life cycle of the workflow. That one takes care of this user tasks. And we have this user or group callback component. That's the one which is responsible for the authentication, authorization whenever this human interaction is part of a process. Persistence, as I said, it's used for the recovery strategy. It's used basically when a process has failed due to some reason, some technical reason. So we need to kickstart the process in a different thread, in a different cluster, in a different server. Then we need to then the system needs to know from where it needs to start the failed process. So that recovery information is stored by the JBPM in the database using the persistence stuff. And we have this history or audit log component which makes sure that all the historical data, whatever process instances have occurred, like executed, failed, aborted, the data that it went through, all this data is stored by this component into the database. And that's for human readability, that's for business activity monitoring, for metrics collection, to create some dashboards. That data will be used for all that purpose.